The current theory on the formation of the Great Lakes are as followed. The Great Lakes began to form at the end of the last glacial period or ice age, around 14,000 years ago. As retreating ice sheets exposed the basins they had carved into the land, which then filled with meltwater. At the heart of the formation of the Great Lakes is the theory of an ice age. Today there is no explanation as to what event could have triggered the global cooling. We accept the ice age theory solely on the evidence of glacier scarring that is found in the area of the Great Lakes. The tectonic plate theory implies that North America hasn't changed its position or shape over the last 10,000 years. However, we know from GPS technology that the crust material is in a constant state of change. In the northwest part of the United States, the GPS technology shows us how crust material moves in every direction. As you can see, in the country of France the crust material movement is extremely fluid and complex. It is clear from GPS tracking of crust material that the tectonic plates do not move as a solid plate. The tectonic wave theory states that the primary force on tectonic material is new material produced at the ridges. The new material is constantly applying pressure on the crust material and shaping the continents. In the tectonic wave introduction video, it stated that the continents of Asia, Europe and North America were once part of a large continent located at the North Pole. The theory of Magnus Polus states that a large continent moved to the North Pole from the Pacific Ocean. As the continent Magnus Polus moved over the North Pole, it would have accumulated snow and ice. The accumulation of snow and ice may have contributed to the mammoth's extinction by eliminating the mammoth's food supply. Additionally, the continental ice cap would have contributed to global cooling by reflecting the sun's rays from Earth. Once Magnus Polus reached the mid-Atlantic ridge at the North Pole, the ridge split the continent in half, pushing it to the south. Recent GPS tracking shows Alaska, which is part of the trailing edge of the continent Magnus Polus, is still currently traveling to the north, which supports the theory that a large continent may have existed, and the force of the mid-Atlantic ridge divided the continent in half. As parts of Magnus Polus moved south from under the ice cap, it would have caused tectonic scraping or scarring on the crust surface. Today we contribute the scarring we find on rocks to an ice age and glacier activity. Currently this is the evidence that supports the theory of an ice age. The tectonic wave theory contributes the scarring we find today, as the result of crust material moving south from the North Pole, from under the ice cap of the continent Magnus Polus. The scarring occurred when the crust material was at the North Pole. Because areas have glacier scarring, glaciers are the suspected force behind geographic features. Most glaciers around the world today flow down mountains, and gravity is the force behind the movement. As glaciers move downhill they scrape and carry material with them. This is not a dredging process. And when glaciers retreat, glaciers do not actually move backwards, it is a melting process. The tectonic wave theory contributes tectonic tearing to the force that tore Magnus Polus apart. As parts of Magnus Polus moved south, it carried the glacier scarring to where you find it today. Because new ridge material is always exerting force on the crust material, tectonic tearing is also responsible for the formation of the Great Lakes region. The Mid-Atlantic Ridge at the North Pole produces tectonic material at a slower rate than the Mid-Atlantic Ridge in the southern region. The slower material traveling south is pulled apart by the faster material moving west. This has caused tearing and flexing of crust material between eastern parts of the United States and Canada. It is this tearing that created the St. Lawrence Seaway and the Great Lakes. The Great Lakes region has a great deal of evidence that supports tectonic tearing. However, because there is glacier scarring located in the area, glacier activity is given the credit to the formation of the Great Lakes. For example, it is believed that glaciers are responsible for the formation of the Finger Lakes that are located in the state of New York, just south of Lake Ontario. Lake Seneca, the deepest of the Finger Lakes, is 618 feet deep. In the southern area of the lake, the land rises an additional 700 feet above the lake. A glacier would have had to cut a 3-mile wide trough, that is 40 miles long, through 1,300 feet of tectonic material. On Earth today, there is not one glacier that is carving a lake in the same manner. The Finger Lakes are an example of tectonic flexing and tearing that created cracks in the tectonic material in the area. If you look closely to the area north of the Finger Lakes and Lake Ontario, you can see more evidence of tearing in the crust material north of the city of Peterborough, in Canada. This continues up into Georgian Bay through Lake Superior. Scientists want to contribute these lakes to historical glacial activity. However, we can feel the Earth move in these areas today. The seismic activity that is found in the region is evidence of the movement of the crust material. Yet this evidence is being ignored by science. Areas where there are no fault lines or plate boundaries, there is seismic activity. The earthquakes we feel today is the evidence that supports the theory that the Great Lakes were, and are currently being formed through the process of tectonic tearing. If we can feel the Earth move today, why is it so hard to believe that the glacier scarring found in the region moved from the northern region to where it is today? Yet we believe in an ice age, and we can only speculate as to what may have caused the global cooling. In Michigan, there is evidence that the Saginaw Bay was formed after Lake Huron was formed. That forces toward the Thumb region to the south and is being pushed east at a faster rate. This has caused an impingement in the Michigan Basin, in the areas of southeastern Shiawassee County and parts of the northeastern part of Livingston County. As we can see here. Further, based on the seismic activity, the lower peninsula of Michigan is currently being pulled apart along the Saginaw Bay, and continues through the city of Grand Rapids all the way to Lake Michigan. As we look at the earthquake hazard map, and then the topographical map, we can see where the lower peninsula is being pulled apart. Overwhelmingly, GPS technology is disproving the tectonic plate theory, and supporting the tectonic wave theory. It is clear that there are forces on tectonic material not related to tectonic plate boundaries, and crust material is moving in all directions within small geographic regions. Additionally, scientists cannot explain the forces behind rogue earthquakes not located near fault lines or plate boundaries. The tectonic wave theory states that new material from the ridges is always exerting force on older crust material. This is the cause of seismic activity. And where we feel the Earth moving, it is an indication that there may be tectonic tearing, flexing, and cracking occurring. The tectonic wave theory accounts for the geographic features we currently see on Earth without abnormal events, such as an ice age or glacier activity. Behind both the continental drift and the tectonic plate theories, is the concept that the continents are moving as one solid body. The tectonic wave theory states that there is ongoing forces on tectonic material and the material moves as the result of those forces. Currently, GPS tracking of crust material verifies that the movement of crust material is ongoing and is complex. Today, it is clear that crust material or the continents do not move as one solid plate as stated by the previous theory.